Okay. Okay, so I hope you've all had a good first 2 weeks of classes so far. Um, Today we are covering chapter 1. So we're doing the tutorial questions on chapter 1, which was revision. So it's stuff we probably still know from high school, right? So the point of the tutorial, of course, is just to make sure we all know how to actually do the work. So I cannot stress this enough. If you have a question, please do not hesitate to ask. The whole point of this session is that we learn and make sure we know what is going on. All right. So these are the tutorial questions. We'll start at question 1 and move on through to question 5. The first question says, simplify the following algebraic expressions. And we will be starting with question A, 1A. All right, so what do we have there? We have 3 to the power of minus 2 plus 2, minus 2n plus 2, excuse me, times 6 to the power of 2 to 2n minus 1, all over 2 to the power of 2n minus 2. Okay, so what we're going to be using here is our exponential laws quite a lot. So first of all, I'm just going to rewrite this 3 to the power of minus 2n plus 2. Now, I'm sure we all know that 6 is actually 2 times 3. And we have a 2 here and we have a 3 here, so it might be better to decompose this into a 2 and a 3. And that's all over 2 to the power of 2n minus 2. Now, as I said, we'll be using our exponential laws. So if I have something like this, I can, with an exponent, I can multiply, or I can apply the exponent to the 2 and apply the exponent to the 3. So over here, I'm going to have 3 to the power of minus 2n plus 2. We haven't touched that yet. Times 2 to the power of 2n minus 1 times 3 to the power of 2n minus 1. And that is still all over 2 to the power of 2n minus 2. Now we can use a different exponential law that says if the exponent has the same base, like so, we've got a 3 to the power of something and a 3 to the power of something, I can add those exponents together. So over here, I'm going to keep my minus 2n plus 2, and I'm going to add my 2n minus 1. Furthermore, I have the same base here and the same base here, but I'm not multiplying now, I am dividing, which means that I can subtract. So I will subtract this, I will subtract this exponent from this exponent. So that means I've got my 2n minus 1 minus my 2n minus 2. Now all that's left to do is simplify this. So I've got 3 to the power of minus 2n minus 2n plus 2n, which will give me 0n. And then I have plus 2 minus 1, which will give me 1. So I have 3 to the power of 1, which is just 3. Multiply that. Now first we have to take account for this subtraction. So that's going to be 2 to the power of 2n minus 1 minus 2n minus minus 2, which will give me a plus 2. And finally, I can complete that simplification, which will give me 3 times 2. Now we have 2n minus 2n again, so that's 0n. And then I have minus 1 plus 2, which is 2 minus 1, which is 1. which is 3 times 2, which is 6. So a lovely round whole number for question 1A. All right, if you have any questions, feel free to unmute yourself or drop it in the chat. Otherwise, we will carry on to the next question, which is B. So here we have a binomial. We have two terms in those brackets. And here we have a trinomial, which is those three terms in that bracket. Now we're going to multiply those two brackets together, which is quite a process because we have so many terms. So the first thing we're going to do is multiply this 3x cubed by everything in these brackets, and then we're going to multiply this 2x squared by everything in these brackets. So what are we going to get? Our first step, we're going to get 3x cubed multiplied by this whole set, this whole trinomial over here, minus x plus 1. Then we have a plus 2x squared, also multiplied by that whole trinomial, 4x squared minus x plus 1. Now this is looking a lot longer, but a lot easier. So we can now multiply in this 3x cubed into each of these terms. And what am I going to get? I'm going to get 3 times 4, which is 12. X cubed times x squared, which is x to the 5th power. Then I have 3 times minus 1, which is minus 3. X cubed times x will give me x to the 4th power. And finally, we have a 1. So we just have 1 times 3x cubed. Moving on to the next set of multiplications we have to do. We have 2x squared, and we want to multiply it by 4x squared. And then we want to multiply it by minus x, and then by 1. So 2 times 4 gives me 8. X squared times x squared gives me x to the 4th power again. Minus 1 times 2 gives me minus 2. X squared times x gives me x cubed. And finally, 1 times 2x squared gives me a nice, neat 2x squared. All right, now we can see, is there any simplification we can do? So if we have a look here, we've got an x to the 4th power and an x to the 4th power. Then here I also have an x cubed, and here I have an x cubed. So I can do a bit of simplification. So our x to the 5th power is going to stay like it is. Then we've got our minus 3x to the 4th plus 8 times x to the 4th. So that's minus 3 plus 8. 8 minus 3 is 5 times x to the 4th power. Then we have a look at our x cubeds. And that's a 3x cubed plus minus 2x cubed, which gives me a 1x cubed, or just a x cubed. And then what's left? We have a plus 2x squared. Nice and simple, right? So that is multiplying a binomial by a trinomial. If there are no questions, we'll move right on ahead to C. Okay, what do we have here? So we have two fractions, as we can see, and we are dividing them by each other. Quite a scary operation, right? But we have a handy little trick that when we are when we are dividing fractions, let's say we have a over b divided by c over d, we can do a neat little flip trick. So that is going to be a over b times d over c. So notice that this is the reciprocal of this, or it's just flipped around over there. And our divide becomes a nice, easy multiplication, which is a lot nicer to deal with than a divide when we have all these fractions. So let us perform that little trick. So the first fraction is going to stay the same, x squared minus 4y squared. Then we have a denominator of 3x squared y squared plus 6xy cubed. Someone have a question? All right, if you have no question, can I ask that you do mute your microphone? All right, I've performed that action for you. But if you do have a question, please feel free to unmute yourself. Let me just get the chat back over here. All right. Okay, so we have our first fraction. Now our divide becomes a times. Yippee, yay for us. And this fraction is going to flip. So our denominator becomes our numerator, which is 3xy squared now, all over the trinomial, which is x squared minus xy minus 2y squared. Okay, now I'm sure some of you may have noticed already that these denominators are factorizable. So factorization is going to become your best friend in this module, in all maths. Whenever you do some algebra, factorization is going to be your best friend. So get to know him well. So first of all, our numerator, we can factorize using difference of two squares, which is going to give me x minus 2y. So we can see we have an x squared, we have a y squared, and we have a 4, which is 2 squared. And that'll be x minus 2y, x plus 2y, all over. Now we can factorize this as well. We can see that 3 is a common factor, since 3 goes into 3 and 3 goes into 6. X is a common factor, and y squared is a common factor. So we have 3xy squared. We can pull that out, and we're left with an x plus 2y. Right. Sorry, I forgot my y up here. That's going to be handy in a moment. Multiply that by 3xy squared all over. Now we can factorize this as well. Now, how are we going to factorize this one? Let's factorize it on the side. So we've got x squared minus xy minus 2y squared. Now, I'm sure many of you can do this in a single step. In case you cannot, we've got a 2 here and a 1 here. So we're looking for factors of minus 2. That'll give me a minus 1. So what factors of minus 2 do I have? I've got 1 and minus 2, and I've got minus 1 and 2. If I have minus 1 plus 2, that's going to give me a 1, but I want a minus 1. So if I have a minus 2 plus a 1, that gives me a minus 1, which means I can separate out that term like so. Minus 2xy plus xy minus 2y squared. I would like the 2's to be next to each other as well as the minuses. So I'm going to reorder this. What do I get? X squared plus xy minus 2xy minus 2y squared. Now I can do some grouping, and I'm going to consider this. Right, so for my first group, I can pull out an x, and I'm left with an x plus a y. For my second group, I can pull out a minus 2y, and I'm left with an x plus y. Now we're using common factor factorization. So we can see these brackets, the x plus y and the x plus y are exactly the same. So I can pull out that as a common factor, and I'm left with a x minus 2y. All right, but as I said, I'm sure there are some of you who can do that in a single step, but just so we all on the same page, that's the drawn out explanation. So we have x plus y, x minus 2y over here. And now the most fun we're going to have in this question is we can just cancel out some things. So we can see here in the denominator, we have a 3xy squared, and here in the numerator, we have a 3xy squared. So bam, 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 we can cross those out. But that is not the end. We can do some more. So here we've got a x minus 2y. Here we've got an x minus 2y. So what am I going to do? Bam, 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 bam. How lovely is that? Already this question is diminishing in front of our eyes. Now we've got a x plus 2y over here and an x plus 2y over here. We're going to do one big bam, bam. Now we can see all that we're left with is this x plus y in the denominator, and hence my answer is going to be 1 over x plus y. Beautiful. We have reduced that massive question down to a tiny little answer. And that is exactly what we want to see. All right, once again, if there are no questions, we will move straight ahead. But if there are questions, please feel free to ask or drop it in the chat. I would love to chat with you guys. Okay. Now we are doing something. Now maybe you did this in high school. I know sometimes math teachers like to do long division of binomials and trinomials. But if you are like me, you did not do this in high school, and you had to learn it later on in university. But whether you are part of Group A or part of Group B, we are going to do this question together. So we will all end up knowing what it's all about. All right. So the first thing I'm going to do is I'm just going to build my little house. So I'm dividing x cubed plus 4x squared minus 5 by x minus 1. So I'm going to put my x minus 1 there, and I'm going to build this little house. So this works in much the same way as long division of your whole numbers or your decimal numbers, which you would have done not in high school, but maybe in something like grade 3. Notice here, though, that we've got an x cubed, an x squared, and an x to the power of 0, which is 1. But we have no x to the power of 1, so we're going to have to insert that in there. But since it's not actually there, we have to insert it with a 0. Just to not mess up our calculations. So we've built our house now. So now let's see. I'll draw a little line here. I just see that's how some people like to do it. Now I'm going to say x cubed. So I'm going to look at my first term here and my first term here. So if I have x cubed over x, what am I left with? I'm left with an x squared. But I'm not going to write it there, apologies. I'm going to write it over here, x squared. You may also want to write it over here, so it's in line with the other x squared. But I prefer to write it on top of the term that we are actually dividing. Now what I'm going to do is I'm going to multiply this x squared by my x minus 1. So x squared times x gives me x cubed. X squared minus excuse me, times minus 1 gives me minus x squared. Now I'm going to subtract these. So I'll have brackets there, just so that I don't get confused with this minus. So what do I have? I've got x cubed minus x cubed, which gives me a 0. And then I have 4x squared minus minus x squared. So that becomes a plus x squared, which will give me a plus 5x squared. Great. Now, I want to ask, so I'm left, so I'm simply going to remove this 0 here. So what we care about now is this 5x squared. So now I'm going to ask, what is 5x squared divided by my first term over here, my x? 5x squared over x means I'm left with a 5x. Now, once again, I'm going to multiply the 5x by the x minus 1. 5x times x gives me 5x squared. 5x times minus 1 gives me minus 5x. And I'm going to subtract that, but I want to bring down this 0x. So over here, I've got a plus 0x, which is just 0, as I'm sure we all know. So 5x squared minus 5x squared gives me a 0 once again. And then a 0x minus minus, so 0x minus minus 5x squared, oh, sorry, just 5x, gives me a plus 5x once again. Yes, we have another 5x. Okay, so I'm going to remove this 0 because we don't need that. Now we're looking once again at the first term of this x minus 1, which is x. And I'm asking, what is 5x over x? And that is, of course, a clean 5. Now I want to multiply 5 by x minus 1. 5 times x gives me 5x. 5 times minus 1 gives me minus 5. I'm going to bring down this minus 5. So I have minus 5 over there. And I'm going to subtract these from each other, remembering that we don't want to get confused with that minus sign. So 5, so minus 5 minus minus 5 is minus 5 plus 5, which gives me 0. 5x minus 5x gives me 0. So I've got a 0 plus a 0, which is just a 0. And that means there is nothing else to do here. X minus 1, 0 divided by x minus 1 is 0. So we can say that this division gives me an answer of x squared plus 5x plus 5 with no remainder, and we got that answer from the roof of this house over here. All right, so make sure you guys are comfortable with long division. It can be quite useful, maybe even in later years of study. It definitely has popped up a lot in my degrees. All right, great. But now we can move on to question 3. We are speedily moving through these questions. So truly, if anyone wishes to make some commentary or ask a question, please do so. Right, I'm going to let you look at question 3 while I take a sip of my coffee. All right, so question 3 says find all solutions to the following. So that means we want to find values or sets of values for the unknown variable, which is in this case our x's. All right, so let's start with 3a. let's see. That is a typo. So we have three. So we have to have, if we want to find a solution, we need to have a problem, as in we need to have this equal sign here. So apologies for that typo. So we've got 6x cubed minus 9x squared minus 6x is equal to 0. And we want to know what are the possible values for x. So since we have x to the second power and x to the third power, we know that there are possibly more than one x values that will give me a value of 0 for this expression over here. Now, like I said, our best friend factorization is going to pop up all throughout algebra, and hence we are going to see if we can use him now. And I think we can. We've got an x over here, an x over here, and an x over here. I've got a 6, a 9, and a 6. Do they have any common factors? Yes, they do. We've got a 3 goes into that twice, 3 goes into that 3 times, and 3 goes into that twice as well. So I'm going to put this arrow here. This arrow means implies. We do not, I repeat, we do not want to put an equal sign here and then do all our stuff and put another equal sign here, because the equal has to stay in line over here, essentially. So, but to indicate that I'm going to the next step, I'm using this implies symbol. So I believe either this week or next week, you guys are covering logic, truth tables and all that stuff. So perhaps this symbol will already be known to you. Otherwise, you will meet it soon enough. Right, so we're going to pull out a common factor, and we said there's a 3 and an x. And that means I'm left with a 2x squared over here, a minus 3x over here, and a minus 2 over there. And that is all still equal to 0. Now, we want to, guess what? Factorize this trinomial over here. So I will, let's have a look at it. We've got 2x squared minus 3x minus 2. If we look, we've got a minus 2 and a 2. That gives me a minus 4. We want factors of minus 4 that will give me a minus 3. And I already know that is a 1 and a minus 4. So 1 times minus 4 gives me 4. Minus 4, excuse me. And if I add 1 and minus 4 together, I get a minus 3. So let me just make a little line here so we don't get confused what we're working on. So we've got our 2x squared minus 4x plus x, 1x, which is x minus 2. Now I'm going to group this together, and I'm going to group this together, and I can pull out x over here. So I'm going to get x minus 2 over there. And then there's nothing to pull out from this one. Now you can see we've got some common factors, or one common factor at least, which is this whole set of brackets over here. So I'm left with 2, oh, sorry, that's not what I intended. 2x plus 1 from this 2x and this 1 that is implied over there. And I've got that multiplied by x minus 2. Alrighty. Now we can put that back into our equation. Just give me a moment over here. All right, so we can sub that back in. So over here we've got, all right, this is supposed to be an arrow like that, but they get tricky to draw after a while. All right, so 3x times 2x plus 1 times x minus 2. Let's fix this up over there. And that is all equal to 0. Okay, now we are getting closer and closer to the answer. So we know that if I have uh, something like a times b is equal to 0, either a is 0 or b is 0, or they are both 0, right? So that means that 3x is equal to 0, or 2x plus 1 is equal to 0, or x minus 2 is equal to 0. So if 3x is equal to 0, that means 0 divided by 3 and 3x divided by 3, that gives me x is equal to 0. Or over here, I've got 2x. I take the 1 over is equal to minus 1. And hence, x is equal to minus 1 over 2. Or finally, I have x is equal to 2, since I take this minus 2 over, or I add 2 on both sides of the equation. So my answers are going to be x is equal to 0, or x is equal to negative a half, or x is equal to 2. Any of those x values will give me an answer of 0 when subbed into this expression. Great. Then let's move ahead. All right, what do I have over here? I think, yes, do we have a question coming up? Hello. Right, no one wants to talk to me, it seems. Let us look at this question then. All right, so we've got 2 over x minus 3 plus 3 over x plus 1, and that equals minus 2 over x squared minus 2x minus 3. Now, I'm sure we can already guess what is going to happen with this x squared minus 2x minus 3. And if you guessed factorization, you are right on the money. So we've got x squared minus 2x minus 3. How are we going to factorize that, you might ask? Well, just keep watching. So x squared minus 2x minus 3. We want factors of minus 3. That'll give me minus 2. I know that 1 and minus 3 multiplied give me minus 3. And also 1 plus minus 3 gives me minus 2. So I'm going to have x squared. What do I want to do first? My plus x minus 3x minus 3. I'm going to group that together and that together. What can I take out the first group? An x, of course. That leaves me with an x plus a 1. What can I take out of the second group? A minus 3, in fact, which will leave me with another x plus 1. And that's going to be x minus 3 multiplied by the common factor of x plus 1 in brackets. Let me make another dotted line so we don't get muddled up. Now we can continue. So we've got 2 over x minus 3 plus a 3 over x plus 1 equals minus 2 over x minus 3, x plus 1. Now you can see we've got an x plus 3 here, an x plus 1 here, and we've got both of them on the right-hand side. That is going to be handy for what we are about to do. Now let's get rid of our denominators because they're just getting in the way right now. So we are going to multiply both sides by x minus 3, x plus 1, which is all over 1, which is going to sort out this denominator problem for us. So if I have 2 over x minus 3 times x minus 3, x plus 1, the x minus 3's cancel, and I'm left with a 2 times x plus 1. Similarly, when I multiply 3 over x plus 1 times x minus 3 times x plus 1, the x plus 1s are going to cancel, and I'm going to have a 3 times x minus 3. And finally, when I multiply the right-hand side, I'm just making a note there, both sides, since I didn't write it on both sides. And when I multiply minus 2 over x minus 3, x plus 1 times x minus 3 times x plus 1, all of that is going to cancel, and I'm going to be left with a minus 2, which is very nice compared to what we started out with. Now I'm simply going to multiply in my 2 over here, multiply in my 3 over here, and the minus 2 stays as it is for now. Now I want all my x's on one side, but first of all, I can see that 2x and 3x are my only x's, and adding them together gives me a 5x. Now I've got a minus 2 here, and I want to bring all the constants over. So I've got a 2 over there, so I subtract 2. And here I've got a minus 9, so I add 9. Now, yes, I believe I'm still on the right page over here. So I've got 5x is equal to minus 2 is minus 4, plus 9. So that's 9 minus 4 is 5. I've got 5x equals 5. Now I divide both sides by 5. What I do on the left, I do on the right. And I get an x equal to 1, which is quite lovely, considering what a giant question that number b was. All right, I hope everyone is happy with that. I'll give you a second to mull it over as I continue to take a sip of my coffee. All right, then we shall move ahead to C. Now, C is adding a whole new dimension to our solution finding expedition right over here because of this inequality. So we were working with equalities with our equal signs, but here we have an inequality. And as you know, we want to banish inequalities throughout society. Hence, we shall tackle this question head on. So what do we have? First of all, we want to get everything to one side, so we're left with a 0 on our right-hand side. So I've got my 2x cubed minus 2x squared minus 12x. So we are subtracting 12x from both sides. So we can, just like an equation, we can do that with an inequality, and I'm left with a 0 over there. Now, I hope you aren't sick of hearing this word, because you're going to hear it much more. We are going to factorize. So we've got a 2 here and a 2 here and a 12 here. Hence, we have a common factor of 2, since 2 goes into 12 6 times. I've got an x cubed here, an x squared here, and an x over here. So we have a common factor of 2x, and that will leave me with an x squared minus an x minus a 6. And that is all going to be less than 0. So we want x values that are going to give me a negative value when plugged into that expression. Now, once one factorization is not enough, we want more. So we are going to factorize this x squared minus x minus 6. And we can do it quickly now. We have had a lot of practice already. So what factors of minus 6 are going to give me a minus 1? That is a 2 and a minus 3. So I'm going to have an x squared plus 2x minus 3x minus 6. I can group them and take out common factors. That's x plus 2 minus 3, x plus 2, and I'm left with x minus 3, x plus 2. Wonderful. See how fast we could do that now that we had all that practice. I do encourage you, though, to, if you are not that comfortable with factorization, do a lot of practice and try get it so that you don't have to do all this working out. It's actually not that difficult. But if you're happy with that method and you can do it nice and speedily, then go right ahead and keep on doing that. So let's plug in our factorization over there, over here. And we've got that. Now that's looking nice. We can definitely solve something there. So we are going to rewrite this over here, and we're going to say let 2x times x minus 3 times x plus 2, let that all equal 0. So we just want to know, the big question is, when is that going to be less than 0? But to answer that, we're going to ask a smaller question, and we say, first of all, when is it going to be equal to 0? So we know that it's when 2x is equal to 0, which means x is equal to 0, or when x minus 3 is equal to 0, which means we've got when x is equal to 3, because I add 3 on both sides, or when x plus 2 is equal to 0. I don't like that plus sign. There we go. X plus 2 is equal to 0, which is, if we subtract 2 from both sides, we've got x is minus 2. So let us actually start a new slide. So we've got x is equal to 0, x is equal to 3, and x is equal to minus 2. So let's draw a number line. And imagine that this line is straight. And we're going to plug in those values. So if we have let's put a 0 over here. And we have a 3 over here. And we have a minus 2 over here. So at this point, we have 0. At this point, we have 0. And at this point, we have 0. So I want to know if I have a value in this interval, is it less than 0? Right? Is it less than 0? If I have a value in this interval, is it less than 0? If I have a value in this interval, is it less than 0? And if I have a value in this interval, just using different patterns so we don't get confused. Is it less than 0? So we've already determined where it is equal to 0, which is x equals minus 2, x equals 0, and x equals 3. But I don't care for the final answer. I don't care where it is equal to 0 because I want to say where is it less than 0. So let's choose a number in this interval over here. So I'm going to choose minus 3. So that means for x less than minus 2, I'm going to check. So I've got, let's write the equation in the corner here. So currently I've got 2x, x minus 3, x plus 2. So if I plug in a minus 2, that's going to give me minus 4 times minus 5 times 0. No, sorry. We are doing this with minus 3. So I'm plugging in a minus 3 as a representative of this interval over here. So 2 times minus 3 is minus 6. X being minus 3, minus 3 minus 3 is minus 6 again. And finally, minus 3 plus 2 is minus 1. So we've got a negative times a negative times a negative. So this is going to be, let's just work it out, positive 36 minus times minus 1. So it's going to be minus 36, which is less than 0. So we know that for this interval, x less than minus 2, we are going to have a negative, i.e. less than 0. Then for x greater than minus 2, but less than 0, so that's this interval over here, we are going to choose, let's choose minus 1. So plug in minus 1 to my equation, I get minus 2. Minus 1 minus 3 is minus 4. And minus 1 plus 2 is 1. And that's going to give me minus 2 times minus 4 is going to give me plus 8 times 1 is just 8. This is greater than 0. So we are not going to look at this interval in our final answer. Our next interval is between 0 and 3. So we are going to look for 0 less than x less than 3. And I'm going to plug in a 1. So 1 is going to be somewhere over here. So that is within the interval I'm looking at right now. So a 1 is going to give me 2 minus 1 minus 3 is minus 2. And 1 plus 2 is going to give me 3. That's going to give me 6 times minus 2, which is minus 12, which is less than 0, which is a tick. So we are going to look at this interval in our final answer. Finally, we've got one last interval, and that's for x greater than 3. So that is from just after this 3 to positive infinity. Let's choose something. Let's choose a 5. So we've got 2 times 5 is 10. 5 minus 3 is 2. And finally, 5 plus 2 is 7. Multiply that out, I get 140. That is far away from 0 in the positive direction. So we are not going to look at that. So that means that our final answer is going to be 2x times x minus 3 times x plus 2 is less than 0 or negative. or, and we're going to write it like this, x, an element of this interval, which starts at minus infinity, and it ends just before -2, so we're using round brackets. And our next interval is between 0 and 3. To join up these two intervals, I'm going to be using a union, which looks like a big U, and that is going to be from 0 to 3. And that is it. So quite a lot in this one question. We've got all the elements of a algebra question for now in here. We've got different notations, and we've got equalities and inequalities, and some really wonderful stuff that we've just looked at. All right, any questions? No. Then we will move ahead. But please, even if you have a question on question 1 or question 2, you can still ask. Don't be too shy. Okay, now we are moving on to question 4, our second last big question. And we are going to be asked, or we are being asked, to sketch graphs of the following functions. So let's have a look at A. This one is nice and simple. So we have our standard line being in the format y equals mx plus c, where this is my y-intercept, and this is my gradient, i.e. my rise over run. So we know that our gradient, or our m value, is going to be -2, and our y-intercept is going to be 6. Okay, technically not 6. Y-intercept at y equals 6. So let's have a look on this graph. Let's say this is 1, 2, 3, 4, 5, and finally we have a 6. So we know our graph is going to pass through over here. Now we have a negative gradient, so it's not going to go in this direction. It's going to go in this direction. All we need is one more point. What's an appropriate point? I think finding the x-intercept would be appropriate. So if we make y 0 now, we have 0 equals -2x plus 6. Subtract 6 from both sides, and we have -2x equals -6. Divide both sides by -2, and we get x is equal to 3. So if I say this is a 1, this is a 2, and this is a 3, then I can say my line goes through there. And now, with a perfectly straight line, we are going to connect these two dots. And I would like you to employ your imagination to help you visualize how this line is perfectly straight and going through both of those points that we recognized over there. So a nice straight line in the standard form. And that is what it would look like, more or less. In a test and or an assignment, please, unlike me, use a ruler to help you make that line nice and straight. And of course, we use these arrows on the end to symbolize the fact that the line goes on forever and ever and ever. Now we've got a bit of a more interesting graph that we're drawing here. We can see that we have a squared over here, so we can have an x squared. What does that mean? We're going to have a parabola. We are done with straight lines. Um, let's see, how are we going to do this one? So first of all, a normal parabola, right? The standard parabola, the mother graph, some people call it, is going to be over here starting at 0. The lowest point will be at 0. Um, we obviously do not have a standard parabola over here. We've got one that has been shifted downwards by 8 points. So if I go 1, 2, 3, 4, 5, 6, 7, 8, let's put my 8 here, we know that the lowest point or the highest point of this graph is going to be at y equals -8. Now, is this graph going to be a happy smiley face or is it going to be a sad frowny face? We have a positive 2 here. So the coefficient of x squared is going to be positive, meaning we are going to be positive today and we're going to have a smiley face. So we know the graph is going to look something like this. We know its lowest point is going to be at y equals -8. Now we simply want to know uh, where is it crossing with the x-axis. So there are multiple ways you can do this. You might be able to read it off um, from this equation, but I'm just going to go ahead and find the x-intercepts for us. Actually, we can find the y-intercept as well. That would be helpful. So let's start with the y-intercept. So we make x 0. So we have 0 minus 1 squared minus 8. That's going to give me 2 times minus 1 squared minus 8. That's going to give me 2 times positive 1 minus 1 squared is minus 1 times minus 1, which is positive 1, minus 8. And that is minus 6. So if we have minus 7 here, minus 6 over here, I know my graph is going to cut through this point exactly. Now let us find the x-intercepts. So that would mean we are going to make y equal to 0. I'm just going to make some space for us over here. And that is going to be 0 is equal to 2 times x minus 1 squared minus 8. And I'm going to, I can divide both sides by 2, so that gives me 0 x minus 1 squared minus 4. Now I'm going to multiply. What's the quickest way I can get this done is what every mathematician should ask themselves. So if I take over the 4 here and I do this and then I square root both sides. So here I've got a 2, technically a plus minus 2, but we are taking the positive square root is equal to x minus 1. Actually, no, we need to take positive or negative 2. So if I have 2 is equal to x minus 1, then I have x is equal to 3. And if I have negative 2 is equal to x minus 1, that is going to give me minus 1, x equals minus 1. So at x equals 3, 1, 2, 3, I'm going to cut through there. And at x equals -1, I'm going to cut through there for my y-intercept. So I know the bottom of my graph is going to be on this line. I know that it's going to cut them at y equals -6 and at x equals -1 and 3. And so I am going to draw it now. But of course, I need to know um, where is the middle of it essentially. So I'm going to see there's 4 spaces over here between -1 and 3. So I'm going to say, or I know then that the middle is going to be over here, 2 spaces from -1, 2 spaces to the left of +3, and hence this is going to be my minimum. So it's going to go something like this without this curve over here. Let's see if I can freehand this. Ugh. No, okay, this is my last attempt. And then we're going to go back to using our imagination to think about how perfect I'm drawing these graphs. All right. I'm sure you've all seen a parabola, so please do imagine that this is one of those. And that is question 4 done. Then we will move on to the last question. We still have, let's see, 6 minutes. So let us get through this so that we can go enjoy our weekend. Unless you guys have more lectures, then I wish you good luck for those. So find the equation that is parallel to the line 4y plus 12x is equal to 8 and passes through the point 3 minus 4. So we know that there is a line that is parallel to the line we want to find, and that is the line 4y plus 12x equals 8. I don't like it in this form, so I'm going to convert it to standard form. So I've got minus 12x plus 8 over here, divide both sides by 4. What does that give me? Y equals minus 3x plus 2. Okay, so if the line that I want to find is parallel to this line, what does that mean? It means that it has the same gradient. So the line that I want is going to be something like minus 3x plus p, where p is the unknown. So we know that the line passes through the point 3 minus 4. That means that if I put those values into my x and my y, I should get an equation with one unknown. So put my 3 in for x, and then I just need to find p. That gives me a minus 9 over here plus 4 plus p, and that's going to give me 5, p equals 5. Hence, I have both values that I need, and the line I want is y equals minus 3x. So we know the gradient is the same as the line that was given to us, since the lines are parallel, plus 5, which we know must be the intercept, the y-intercept over there. All right, and that is the entire tutorial 1. So, like I said, hopefully next week we are on campus and we can have a more interactive session where you guys can work on the problems and we can share answers together. And we can just see each other's faces. And if you have any questions, we still have time. I will hang around for a few minutes before I end the call. So please feel free to unmute yourselves or put a message in the chat. Otherwise, if you are satisfied with what we have just done, please go and have yourself a lovely Friday. And please enjoy your weekends to the max. Thank you very much all for joining. Like I said, I'm Derek Hill. If you guys see me in the corridors, please feel free to stop me and say hi. Alrighty. Cheers, everyone.